Hello friends, how are you? Hopefully you are enjoying life and you did enjoy my previous video regard to that collab captcha problem. In this video, prior to proceeding with this video on VGG19, I would like to tell you that in that previous video, I explained you how to resolve that captcha problem, and also I am not exaggerating that it is the only solution to that problem, because others have provided various solutions like with regard to the connect button, and only they are providing the solution to click the connect button. That is the only solution they are saying like that. Like in the website, let me tell you that in most of the websites, there is one simple line that document.query selector collapse toolbar, and there we will go to the connect button and click on it. There are many sites, like means in YouTube there are at least 15 videos that are means 15, maybe more than that, but I don't know, but they are providing the solution as toolbar collab toolbar button connect should be clicked, but it is not so. Like in this analyticsdemag.com, there also they are giving this 5 Google collab hacks. What is this simple hack is not working, so how can I expect that the other 4 will work? So but we need to check the checkbox and not the this connect button is separate thing and this collab captcha is a separate thing. So these two are not linked. Click on the checkbox. Even if we connect and connect, that will not resolve the captcha. So the problems are different. So the solutions are different. The connect button may also raise some issues, but that will have a separate solution. So having said that, there are various websites like analyticsdemag.com. There are various sites in YouTube. You will find at least I think 50 videos are there for the collab connection captcha problem. Sorry, and there they are providing the connect button as a solution. Clicking the connect button, how will it resolve? Because captcha is a different issue. I hope you understand and got the point. Then now coming to this video. Um, this video is for the VGG19 explanation for the implementation for the various problems. VGG19. So because if you search on the YouTube, you will find various videos for the VGG19, but they ultimately lead to the VGG16 and not VGG19. There is lot of confusion, and also in VGG19 you will find that they have solved it with one liner, and that is means it is just a built-in, like it is inbuilt thing. In Keras they are directly using the API, but we want to tweak it, we want to modify it as per our customization requirement. So for that purpose I am making this video. So if you want to implement VGG19, if you firstly, I will explain the problems. If you want to resolve the problems, there are lot of problems with implementation of VGG19. And then further, I will explain to you the theory part that is involved in the VGG19 network. There are many pros are there, experts are there who are uploading 2-3 videos daily, and they are simply saying that in max pooling we are having the activation layer. How can it come in the max pooling layer? The activation layer is a separate thing. It is out of the convolution unit, so it is not part of the max pooling. So these pros are explaining wrongly. So I ought to explain, I have to explain how the VGG19 network works and how the implementation is to be made. Hello friends, how are you? Hopefully you are enjoying life. I hope that you enjoy life still in this COVID pandemic, and hope that you are living your life to the fullest. So the thing is that I hope you enjoyed my previous video also. So in that video I explained to you how to resolve the captcha problem. In that many experts have tried to resolve this, but sadly they have come up with the idea to resolve it with some connect button, some one liner like document.query selector. For the connect button they are pushing the connect button, but I don't understand how the connect button will resolve the captcha. So we should click on the checkbox and not the connect button. That will resolve the collab captcha thing. Coding now. So for that I will provide you with the implementation part of the VGG19, not VGG16. It is VGG19. So I will provide you with the solution for VGG19 implementation, 19th implementation plus its problems involved, the various problems that are there. As if you search for the VGG19, there will be many videos which are explaining the VGG16 and its implementation. And further, there is one more thing that one-liners are there. So there is no such implementation where we can apply our own customization to the VGG19 network. That is there. So also there are so-called pros experts who are uploading the videos. They are explaining like this: in max pooling there is an activation layer. There is no activation layer in the max pooling layer. There is activation is only there outside of the convolution. That is also in max pooling where can we apply the activation. So I don't expect from such experts that they tell like that. So let us proceed to this purpose of today, that is VGG19 will be done today with implementation and its theory. And prior to that, I will explain the problems involved in the implementation as well as understanding the VGG19 network. Having said that, the problems that are faced mainly regarding the videos that others upload, but I don't know whether they are making the silly mistake, maybe by mistake, or but surely they know that in place of VGG19 they are pulling with 16's implementation, VGG16's implementation. So let me start with the problems, then I will move on to the theory part of VGG19, and finally I will show you the implementation. So the first thing is that there are so many weight files available and easily available and not also, because we get confused that like here you can see that it is no top. No top means the dense layers are not there, only the convolution part is there, but this is not so easily understandable. It is not that much, means it is not comprehensive. They are just giving the files weight files. Like here it is from Euler, means Yale University it is, and here the means here you have the weight files, like the convolution layers are stacked together. The blocks are having the layers stacked together, not having the max pooling layers in between. So this is the difficulty that we cannot use it with VGG19 model. We will have to make some tweakings in that, and these files may be used directly with the VGG19 model that is available in the API form with Keras, or we can make our own models. This file we cannot use directly in the model because this file is having a different structure, as I have explained to you. This is another file that is not having the it is having the top. So the top is there. Top means the dense layers. I applied the VGG19 on this profile picture and it is detecting it as a, I will show you later on, it is detecting it as bonnet of, means it is really very funny. Then I applied it to a cat picture, and here there are so many weights from other sites like Kaggle. These are from that. So much of confusion is there. So Kaggle, etc. I was really confused at that point of time. So VGG19 is there and other files are here. So there are, means I wanted to implement the model as per my choice, means I wanted to customize the architecture is confusing in different weight files. Means they are confused it all. Somewhere it is providing the whole layers in one go, then max pooling layers in one go, then they are applying some other optimizers. Somewhere they are providing extra layers. So there are variety of files available, but I needed one more thing is there that they have means other videos have explained it in one line. In Keras, we have one simple line by which we don't need to make the model. But I wanted to make my model, means I wanted to tweak it. So I wanted my own model. So how we can take the model from directly from the Keras API? There is Keras applications. We can directly go to this URL and click on VGG19 and directly we are here. So this is the VGG19 function, and from here we can directly import it and use the VGG19 simple one line code to use this. But I wanted to make the model myself because I wanted some tweaking. So this is the first problem, that I wanted the customized thing, and the second problem also incorporated that I had the problem with the weights. There are so many weight files, like it is really confusing. And also I was not knowing that what no top means and other such jargon. Technically it is means technically we should be sound with the VGG16 AlexNet for that case. Means as a matter of fact, I was not knowing about much about the AlexNet network at that time. So I was there. Full model is not available, and YouTube search also fourth problem. Third problem is that YouTube search was also leading me nowhere. It was showing me the VGG16. Then finally I came to this Keras shortcut one-liner, but I wanted the customization. So the pros were claiming that they were having the implementation. Like one was saying that the max pooling is having activation, but all of us know that the activation is after the convolution layer. So there was one problem, and there was another problem in the implementation part. In one liner, I will show you how we can implement the VGG19 network. Okay, now we are here for the theory part. So before I start the theory part, I would like to tell you that this part is going to be very lengthy. So if you don't want to bother about what the VGG19 network actually is, then you may skip this content. And by the way, after you skip, you will get the implementation part from the very beginning. So you can skip it without any loss of context. So the second thing that I want to tell you that I was comparing with other videos, but that was for constructive purpose, for betterment of our understanding of what the basic things they are neglecting things. Like in one of the videos I found that there is an activation layer in the pooling part, so I was really surprised. So basically I did for the progressive sense. In the progressive sense I did for improvement. Okay, anyway, here we have the introduction for the motivation behind VGG and related advanced deep neural networks. Means for the motivation, we are doing the introduction part to know about the motivation. So I'm starting with the introduction. Basically, the idea for this introduction is what is the motivation behind VGG and the other related advanced deep neural networks, so as to get an overview outlook of what and why we are going after VGG19. So the basic developments which led to the VGG coming to the existence is this convolution neural networks, which we call connets in short. They were really very successful. This paper for the AlexNet, then this paper we will see soon. So these papers were really very successful. Convolution networks were really very efficient in recognizing images, objects from large repositories. IMAGENET, this is it is very good repository of various images of various objects. So this repository has been used in many challenges. So means very good challenges have come to existence, and now as we know that GPUs have come into existence and large scale clusters are here, so we need some efficient things, means more powerful recognition is needed. So that became a very high point. Convolution networks became very, means it was encompassing many things. So to build upon these things, we came for the advanced very deep neural networks. As we know that convolution networks are deep neural networks, so we are in search of something even deeper. So advanced deep visual recognition architectures has been played by the ImageNet large scale. This is the challenge that has led to the development of many good architectures, means very those architectures that are just efficient in just every data set, we can say, means those are really efficient. They help in many recognition fields, be it biometrics, pattern recognition, in genetics, in means forensics, or in many means security purpose it is solving. The in every field it will solve the purpose, mean. So these are test bed. These challenges are really test beds for high dimensional shallow feature encoding. This feature encoding to deep connets we have come, and it has been the winner of ILSVRC 2012 AlexNet. They proposed the AlexNet. Okay, so now we are here. It is going to be really lengthy part, so I fear that I forget some part, but bear with me. It will be very informative journey. So here we come to the LeNet architecture. It was for grayscale input images 30 by 2 by 32, like here we have A, and basically it was 5-layer architecture. And actually you may for the convolution network I will make a separate video for the basics of convolution network, how they work. Means it does the multiplication in 180 degree shift, sorry. So the convolution operation, why it is so efficient, I will make a separate video. And these building blocks are really very efficient. So firstly we are here with the history. So history part is very crucial to understand what led to its advent. So LeNet 5 basically, which architecture was finally useful. So here we can go to the Wikipedia pages. I will show you some other pages also, other information, other informative things are also there, not just here. I will encompass everything here. So at that time it wasn't famous basically. Why? Because at that time there was no GPUs these things were not there. So SVM was already there, and it was able to achieve or and even exceed the performance sometimes. So basically GPU was needed to, means it does the things so fast that we know it does what it does in the uh, that it does in at the scale of images. So that was a separate different thing. Like this is the author. So they did it at the Bell Labs, back propagation to practical application. So the basic of this network, it was in 1988. So LeNet was the earliest convolution network. So that's what means, it is the basic of the deep learning. It was the origin for the deep learning. So they did it at the Bell Labs. So this paper described the application of back propagation networks in handwritten digit recognition. That is was their hand black and white. That's why it was grayscale. So the research continued in next 8 years, and in 1998 they yes, I also thought that it is 1998. It is recent because 2012 AlexNet was there, so it was in 1998 near 2000. So these author did it. So this is the development. So coming to our slides, here 5 layer we can see basics are convolution, pooling, and this is its structure. Okay, by the way, I will tell you how to calculate the output size. Like here the output size is 28. From 32, how we get the 28? So this is the calculation. From 32 we subtract the 5 by stride size. So if it is considered as it is 1, then 32 minus 5 by 1, what it is? It is 27. So 27 divided by 1 is 27 plus 1. Plus 1 is every time. Okay, and pooling is also having the same calculation, exact same calculation. And if the padding is also there, if the padding is same, then the same output size result. Otherwise, if valid, then this calculation is there. So for pooling we have it as pooling window size, and in case of convolution we have it as convolution filter size. So this is the basic difference of pooling calculation and convolution layer calculation. So floor is taken. If it is an odd number, then we will take the floor, means lower one is lower end. We are doing it as floor function. So secondly, I'm just checking whether it is recording. So okay, so in internet there are many confusing figures. So but I will let you know each and everything in detail, in every possible detail I will give. So in the input, the image was of 32 cross 32. It is simple network comparison to the others that we are going to see. So the last okay, radial, this one will confuse you, I will tell you later. So here the convolution is done, then the subsampling is done. Okay, I have not shown you the figure. There are 30 means their paper, I will show you 6 feature maps. There are 6 feature maps of 28 cross 28 size. Okay, and from them it will take 14 cross 14. By the way, I think it is not a 3D image, means three dimensional. It is not. It is 2-dimensional. But from AlexNet we will get 3-dimensional. So that was confusing in the internet. They are no giving this filter. Either they are giving the filter number of filters or the third dimension. They are not giving both the entities. So but anyway, we are here in LeNet. For now we will focus on LeNet. So here subsampling is basically pooling, because this suppose we are using max pooling or average. Okay, we will suppose that we are using max pooling, so they will pick up the maximum and maximum, plus it will be subsampled. The samples will be short, means it, the maximum will be chosen out. So it is basically, it is subsample, sample, one sample is taken only. So this part you will get more clarity when we discuss one of the papers, we will see. So feature maps, from these feature maps, again subsampling means pooling. Then C3, in this layer they are getting this, and in this way the things are propagating. 6 number of filters has been used, I guess, and convolution size, as we have filter size we have already seen, 5 by 5, all are 5 by 5, pooling is 2 by 2. So it is very easy to remember network, it is easiest and the basic. So as we saw, it is 5 by 5 con and 2 by 2 pool. So when we do, let us do one calculation here only. 2 by 2 pooling, 2 by 2 14 minus 2 12, and 14 minus 2 12. So I think it is 12 pooling layer, na 14 cross 14. Stride I think is different. So 14 minus 5 by 5 convolution is okay. 14 minus 5 9 by 1 plus 1 10, and then if we apply the pooling layer on 10 minus 2 8 by 1, I think 8 by 2, maybe they are using stride of 2 in the pooling layer. 8 by 2 4 plus 1 5, size is 5. Similarly for the second case, I guess 5 minus 5 divided by 1 plus 1, means in pooling layer they are using stride of 2, that is what is making it different. And fully connected layer, it will not do any means specific picking up, it will do it on the entire image. Every node is connected with every other node, that is why they are heavier, and that is why we went for the convolution thing with kernels. For that purpose only we are doing it with means least things, otherwise fully connected means 1 to 1, many to many, sorry. So that is why fully connected layers are not of that much of efficient. So Gaussian function, this is Gaussian connections are what internet says is that these are radial connection. Radial means, like we know na, that Euclidean, in basic sense I will tell you, like Gaussian distance is there, so that distance somewhere it is used. So I will create a separate video to explain it. By the way, these are radial basis function, these are Gaussian function is a radial basis function, and this means radial based, like in the place of it is layer that uses Euclidean radial basis functions for each class to estimate the lack of fit between input, like we were lack of fit by loss function we are calculating with means some loss function. Similarly we are using this class of radial basis function, and the output predicted. So in this way the output is calculated. I will make a separate video for that if you ask. Then we are here in the AlexNet, the confusing architecture as compared to that LeNet. Before that I would like to show you the paper of LeNet. So this was the paper that they wrote. Multi-layer trained with the back propagating algorithm, best example of a successful gradient. Yes, gradient is calculated, na, that loss, that thing I was saying, this is the main thing. I didn't say, but this was the thing. So traditional pattern recognition, this was they were unhappy with, is performed with two modules. This is the basic paper, a popular maximization procedure. So if you are unclear with your basic gradient based propagation, you must read this paper. So how the gradients are calculated, how they are incremented, these things also will be clarified. Globally trainable patterns for isolated, I have read half, means most important things I have read, and I have made it whole paper highlighted so it looks dirtier. That's why I am showing you the cleaner and original version of the paper. For isolated character, yes, this LeNet was used for in banks for check signature, means character recognition. It was able to perform very well in that. It was used in secure privacy cryptography, that you know now. That is what it was used for, signature recognition. So this receptive field thing we will cover again later stage. In the first hidden layer, the receptive field units overlap 4 column 5 rows. This convolution layer things, these things you can, this was the because I gave you the right thing at right place, so I gave you the original architecture itself. So LeNet 5, this is C1 C2. Each column indicates which feature map in S2 are combined by the units in a particular feature map. So which feature goes out, which feature doesn't. These are all initial parameters. So you can see they have compared with on the MNIST set modified NIST. This has the digits. So you can go through this paper. If I do so, then it will be very lengthy video. So I better switch to the presentation mode and give you the brief about AlexNet. So that what happened? Okay. So AlexNet, here we are having some complicated things. So here you can see the image size is 2. Yes, here there is conflict with this also, controversy over this size also. So much of controversy is there because they don't know the actual size of the image itself. And somewhere in the internet you will not find all the 3 details. So here if we use 2 to 4, one more conflict is there, that is also not addressed in the internet. So here you can see, okay, let me first brief how the things are calculated. In 2 to 4, stride is 4, and the first layer which uses this, I have written 2 to 4, see, it is 3D image. So first layer, the first layer uses 96 kernels of size 11 cross 11 cross 3. So 2 to 4 minus 11, 213 by 4. 213 by 4 means 212 by 4. 4 5 is 20. 4 5 is 20. And okay, I was right. So it will output 55. 4 5 is 20 and 4 3 is 12 plus 2, plus 1. So it will be 254 if we use 2 to 4, but it is 2 to 7, so it will be 55. Okay, so the output will be 3 channels are there, so third dimension is for the number of channels, I hope you know. So it will be 55 cross 55 into 3, and again the convolution layer is different. Here what they have done is 44 number of filters. It is number of filters. See here, one extra 4 parameters are there, 3 for dimension, 1 is for the number of filters, so it is 896. okay, so they have half is they are showing half for the inter GPU and half for the intra GPU. That is a separate problem in itself. In many figures in internet they say it is okay. Let us focus on this. So then afterwards, in the max pooling layer, they are using this 5 cross let us see. Okay, first, yes, here we have 5596 kernels. Okay, so in the 55 first output they will apply the max pool. Okay, on the 55 cross 55 they will apply max pool. But in the figure you will see, in many figures, like here I have shown many figures, in output 555 cross 55 they are showing convolution. Like here you can see 55 cross 55. Here the 55 cross 55 is having applied the max pooling layer, but they are showing it as convolution C2, because where the C2 has vanished. C2 is to be applied on the output from 55, means it is to be applied on 27 and 256 such. 256 are to be applied on the output of 55. If we assume it to be max pooling, then again one layer gets if we assume this is max pooling, then also there is error. Okay, so I will explain to you each and every layer now. The thing is just that 55, okay, I will do the calculation here. Okay, pointer, I will show you the calculation, which is very essential. The basic thing is that if we apply the pooling layer on 55, then C2 cannot be applied on 55. I will show you how the calculations are. So here 2 to 4 by, okay, it is 2 to 7. In 2 to 4 I have calculated and we got 54 now. Only 2 to 7 will qualify as the correct figure, 2 to 7 or 2 to 8 even, but as we have in wiki that it should be 2 to 7. Okay, then 2 to 7 minus 11, 2 to 7 minus 11 by stride size 4, so we will get it as 2 to 7 minus 11, 216 by 4, 5 is 20, 4 4 is 54, plus 1 55. So 55 is calculated. Now as we have this 55, so in 55 we are applying the max pooling layer, and that is having the stride of 2. Each max pooling layer is having the stride of 2. Then these strides are not written in the paper. The paper is not means explaining, the AlexNet's paper is not explaining the strides, neither it has explained how 2 to 4 will give 55 with stride of 4. This stride was written, only this was written, I think. And means convolution strides were not written except for the first. So from 55, if we apply max pooling layer with stride 2, then what happens is that 55 minus a pooling layer with size of 3 by 3. Each pooling layer is of 3 by 3, so there is some regularity. So 3 by 3, 55 minus 3, what we have, 51, and 51 by 2, what we have, 25. As we know that we will have to take the floor, so 25 plus 1, what we get, 26. Oh, 26. Oh, so 51, 55. Oh, so 55 minus 3. 55 minus 3, so it should be 52. Okay, 52 divided by 2, 26 plus 1, 27. So here we get the 27 figure. So this 27 should be applied upon by C2 layer. So this should be here. So that's why the figures in internet are not correct. Like, see, this is somewhat correct. In 55 we will be applying the convolution, pooling layer. Here we will apply pooling layer. Okay, we can consider it like it is vertically saying, but the output will be applied upon. So this will be applied on this. We will get 27. Convolution is having padding of same, we will assume. So the output will be 27 will pass on to here. On 27 we will apply this. So it is somewhat correct, but this figure, see, the number of filters is same, 256. Okay, here they have given the number of filters. Here they have, okay, here also they have given the number of filters. But what about third dimension? That is the number of channels. Where it is? Where is it? So there is some missing part, as I mentioned. So back here we are having 27. On 27 they are applying this pooling layer. Pooling this 27. On 27 they are applying the pooling layer. Okay, and on the same 27 they are applying this pooling. This is the pooling layer which gets applied to this size. Is 27. On 27 it will apply on 27. Why? Because from 11 when we apply this, from 11 we got the 55, this output. Okay, and when we get this output, then it is applied upon by this pooling layer. Okay, so when this, okay, let me clear it. Okay, so here we have this thing output from there, and it is applied upon by this. So it will give us 27. So on 27 the second convolution is applied. So C2 is applied on 27. C1 is applied on C1 is applied on full figure. C1 is applied upon the full that thing, and see from that we get 55, on which the pooling layer acts upon. So on 55 C1 never gets C1. This is wrong. C1 is applied on the full figure. This is wrong. Full figure. So on 55 convolution is never applied. Pooling was applied on this, because its stride is 2. Only pooling, and they have not said. So after the pooling is applied on the 55, we get the 27, and on that C2 is applied. C2 is correct. C2 is correct. Then from C2 we have 3 convolution layers. Firstly we have from C2 we will apply the pooling layer, and because of the pooling layer, 27 minus 3 by 2, so we will get 24 by 2, 12 plus 1. So it will give us, okay, 27 minus 3, 24 by 2, 12. Yes, correct. 12 plus 1, 13. It will be 13. This is also, here also there is means mistake. So on 13 these 3 convolution, as these are having the padding same, we assume, like in here also we assumed, because 27 was passed on. So if 27 is passed on, because this never the thing is, convolution layer never faces the 55, because pooling was before it. So because of pooling it never faces the 55. And similarly these convolution, if the calculation till now we have done, you may check that I have applied because of the pooling layer. This convolution didn't play any role. So we assume that these 3 are also having padding same. So because of that, this 13 gets passed on here, and on this pooling layer is applied, and because of that we are having 13 minus 3, 10 by 2, 5 plus 1, that is 6. Okay, so this will give us the output as 6. And by the way, let me tell you the details of the layers. So, okay, I will let you read it in, see here it is 6. These are the number of layers, 96, 96, then 256, 256, 384. These number of filters are, see here same is also written. So, this is the total size of the filter. So final filter from the max full, which passes on to the fully connected layers. So we will head on to the paper now. As we have seen all the calculations, there will be this data set detail I will give. There are 1000 classes, so you can see how much of improvement we have got after LeNet, which was doing such, means only on the black and white images for character recognition, and these are for images, so these will recognize the objects. So it is very, means high end as compared to the LeNet. So let us head over to the paper, and here you can see that to identify 1000 and 1000 classes 2 to the power this many, if we do whether, means it will be too much. So okay, so here we are on the paper. It is very difficult, this paper, if we don't know the basics. So here see these many, the network is 155 to 8 dimensional, number of neurons, remaining layer is this, these many, they have counted the neurons, and finally the fully connected layers are having all the neuron connections 1000. So the third dimension that is missing, we are having the kernel size 48. So these dimensions were not there in the figure. See, the third dimension was nowhere to be seen. The third dimension was nowhere. 3 cross 3. These are number of filters. You can see there is nowhere the third dimension. So in my slides also I have given the third dimension. See, the second takes as input 11. This thing is 3. Stride of 4. So second convolution takes as input output of the first, and to 5 second convolution layer is having this size. Okay, 48. Third dimension is 48. So it is important. 96 filters, and on that third dimension was this much. See, third dimension is 48. So 48 is not a small number. First output was having the third dimension as 3, and on top of that the second kernel was, secondly pooling was applied, and second convolution layer was applied, and there were 5 cross 5 cross 48. 5 cross 5 cross 48. Okay, here 11 cross 11 cross 3, and it was 5 cross 5 cross 48. Similarly, in third, fourth, we are having this dimension. Third has 384 of 3 cross 3 cross 256, then 3 cross 3 cross 192 192. So here we go, and so the output of the last fully is fed to 1000 wave softmax, which produces over 1000 class levels. This network maximizes the multinomial logistic, like we use the Gaussian radial function. So here we have this, which is equivalent to maximizing the average across training cases of log probability of the correct label. Okay, so something is maximized, definitely that's how we get the output. So reading the paper, overall architecture we have understood. Here we get actually the pooling layers are preceded by the normalizing layers, and ReLU has the desirable that they do not require input normalization.
So okay, it was in LeNet, not here. So here also somewhere normalizing is done by the ReLU layer, so we can say it like that. Still find that the following local normal its generalization, denoting okay, so they combine both. That is the case. Yes, I read it, so I know that it was there. The response normalized activity is given by the expression this. So here they have normalized it with applying the ReLU nonlinearity. Okay, alpha is there. So ReLU nonlinearity, you can read, it is not that difficult. It will give the nonlinear response. That is the case. And see, they have used GPU. I guess it is in my slides. So here you have the this is the means basic function, basic style of ReLU. Okay, ReLU is this max. ReLU is this. So this is the basic style of ReLU, and this is its uh, means function. So I'm going to switch on the light because it is dark here. So we have got the ReLU function, not deviating towards the ReLU function. Here ReLU nonlinearity, overlapping pooling. They have explained what is overlapping pooling, overall architecture. Okay, back. I will explain to you the ReLU functions, etc. This is the ReLU function, and this is the tan-h function. Okay, hyperbolic it is. So sine by cos, sine was minus, cos was plus, exponential something, and this. So okay, let me explain to you the paper from the very beginning, because I wasted some, means it not wasted, I devoted my time to one very important paper, that is making convolution network shift invariant. So this paper is very in-depth paper. I think they have given a very, but there also there is some mistake, like in this figure, shift invariant, same thing they are doing here, but they are saying it is reduced aliasing, it is heavy aliasing. So whatever be, but the point that I was in depth, I lost. I got, means I deviated somewhat, but it was good deviation. So convolution layers are shift, convolution networks are shift equivariant, sorry, capsule networks are totally equivariant. Here these are shift equivariant convolution, and pooling layer is shift invariant. So they are making, because of the strides in both convolution and that, they have become non-invariant, but they have tried to make it shift invariant again. So as you know, you will think that I will devote one whole video to convolution. So here I will not explain. So see, I have explained convolution also. So back to our paper of AlexNet by Alex Krzyzewski, so University of Toronto. So see, they have done it on such a high 1.2 million high resolution images, and data achieved top 1 and top 5 error percent of this. So see, 37.5, 17.5, and it is invariant to pose and lightning. See here, pose invariant. Okay, and these all they are able to, and yes, from here I deviated. Convolution or shift equivariant, pooling builds up shift invariance. So here it is able to extract the features of a mite and black widow, etc. I will implement the VGGNet. There you can feed any of your images and the model will perform very well. It will, even if it errs, it will make very good predictions. So it will be nearby. If you give it your image, it will definitely identify, at least like you are a girl or a boy. At least it will identify most of the features, until and unless you do not provide it proper lighting. So back to the paper. Here I have explained it, and then 60 million parameters, 6 lakh 50,000 means 0.65 million. This neurons, 5 convolution layers, as we have already seen, max pooling layers. So 5 convolution layers total, and 1000 way that I have already mentioned. There were, means this competition is very tough, and training faster. They used non-saturating. See, by this time GPU was available, so they got benefited as compared to LeNet. Non-saturating neurons, you can search this term. I will not extend the video. And winning top 15 entered a variant of in this, achieved a winning top 5 error rate, and compared to 26 achieved by the second best entry. Okay, variant of the model, that is the, means it is its variant, this model in the 2012. Okay, and the data set was from 2010. So they used the data set from 2010 but achieved in 2012, and the reason also they have given the labeling something, and rate you have seen. So here we have approaches to object recognition. Machine learning methods are really very important, and without that many fields are really in tatters. For example, the current best rate is digit recognition is 0.3%. Okay, current MNIST digit recognition, okay, which database we saw. And convolution constitute one such class of models. To learn about 1000 from million images, we need model with large learning capacity. This is immense complexity, IMAGENET. So prior knowledge to compensate, prior knowledge is required by CNNs or such models. Fewer connections, GPU 2D convolution. Luckily, GPUs paired with highly optimized implementation of 2D. So we are here for the data set. I told you in slides I have is separate very good insight about this paper, convolution layer, which is the basic of the VGG19. So these are it is the history part, so I focused on that paper more. So anyhow, I will do it in fast mode. So here we have 22,000 categories. The images were collected from web and labeled by human labelers. Okay, this, I think this model won the competition, and that VGG19 was second. So anyhow, we will get to know. So starting as part of Pascal Visual Object Challenge, an annual called ImageNet large scale, VGG also competed in this competition only. 1000 with roughly 1000 images it trained. In all, there are 1.2 million training, 50,000 validation set. Okay, so ImageNet is very big data set. So 1000 in 1000 means 1, 10, 100, 1000, 10,000, lakh, 10 lakh, 1 million. Okay, 50,000. This was ImageNet structure. L2010 is the only version for which the test set labels are available. See, due to the test set labels, they use this data set. So in this competition, report our result on this version as well. It is to report 2 error rates. Top 1, where top 5 error rate is the fraction of for which, see here you can get explanation for the term of top 5 error rate. Okay, test for which the correct level is not among the 5 levels considered most probable for the image. Is not. When it is not, it is error. So if it is not amongst the top 5 probable, then it is error, and it is in the top 5 error. So that rate they have calculated. So they have constructed from the 256 cross 256, uh, uh, cropped out the central 256 patch, and they got it as 256. Pre-process was not done, subtracting the mean. So we trained on raw RGB architecture, training on ReLU, and deep works with ReLU several times faster from equivalent 10H units. That is why ReLU is used. Training on multiple GPUs. See, a single GTX has only 3 GB memory, which limits the maximum size. 1.2 million training examples are enough to train networks. That 1.2 million training examples are enough to train networks which are too big to fit on one GPU. These networks, 1.2 million training examples is enough, but it will not fit in one GPU. That was the problem. So what they did, the parallelization, they used parallelization 2 GPUs. Net across 2 GPUs. Current GPUs are so that's why they I showed you the image. There was two part. It was bifurcated, so that's why. So now we get the idea that why it was bifurcated. The parallelization scheme essentially puts half of the kernel neurons on each GPU with one additional the GPU only in certain layers. So communication burden was reduced, and it time also reduced. This means anyhow we get the idea that they have used 1.2 million images training examples that we saw there. So here local response normalization is incorporated into ReLU nonlinearity. See, it is a nonlinear inducing function. It introduces nonlinearity. So effectiveness on the a 4-layer CNN, only a 4-layer CNN, they just for the verification of its effectiveness. 13% test without normal, 11% with normalization. So they already checked this. Overlapping link, you can read about this topic, how the layers is as pixel apart, each summarizing a neighbor of size z cross z centered at the location of the pooling point. So here they have given the criteria if the pooling is overlapping or not overlapping. The neighborhood summarized by a unit do not have overlap. Okay, so neighborhoods, something to do with the neighborhoods. So not extending the video, overall architecture we have seen. This is the reducing overfitting, 60 million parameters, 1000 make each training example impose 10 bits. See, this 10 bits constraint is there. 10 bits constraint of mapping from image to label. Okay, 10, 1 to 1000, 1000. Okay, 10 bits is required. Constraint on mapping from image to label. Okay, but here I was confused that 2048, yes, how come this 2048 number from 10 bits? Even if I assume that it is 10 bits of constraint is there, 2 to the power 10, it will map 1024. Okay, so 1000 classes needs 10 bits, that is correct. But okay, firstly we do this. These are references. we employ two distinct forms of data augmentation. So augmentation is said original images with very little computation. So transform do not need to be stored on disk. Okay, disk saving, Python code on CPU, GPU is training batch of images parallelly they are processing. Okay, from here I was confused why this 2048 2 to 4 was extracted. Okay, I knew that random 2 to 4 patches were needed. There they were saying 256, 256. Finally, they have come to this 2 to 4. For whatever reason, they said that 256, but finally it had to be 2 to 4 only. That is how we have seen the architecture to work on the images. So the increase is the size of our training set. So this calculation I was confused. So for this I remember this thing 2048 1024, you know, and for the two, because here see 256 minus 24 is equal to 32, 2 to the power 2 to the power 5, 32. Okay, this increase for 1, and for 2 it is 2 to the power 10 if we increment the total increment. This much of this is processing is training set is increased, and 2 to the power 10, and due to this horizontal reflection it will get 2 times, that is 2048. Okay, at test time the network by extracting 5 2 to 4 patches. Okay, so this thing they have 5 times it is done. Data augmentation, they have done 2 types of data augmentation, PC on the set. Okay, this you learn about PCA, then only you will get the idea. By the way, eigenvectors, it is in the basics of the course. Pattern recognition and artificial intelligence also has this PCA. Okay, so drop out, some neurons are dropped so that the same effect can be had from less number of neurons. This, if you do machine learning implementation, the neurons which are dropped down in the way do not contribute to the and do not participate in the back propagation, but effect is the same. Okay, details of learning. Batch size of 128, momentum of 0.9, weight decay, stochastic gradient descent. Okay, you must be knowing the gradient descent, batch gradient descent, mini batch, stochastic. You can, I will make one video better to explain the 3 differences are many. So basic difference is that it will take each example one example in calculation, while batch mini batch will take it it will assume from one example the whole stochastic, and in batch they will take the batch to calculate the whole batch will be taken for the calculation of the gradient, and in mini batch will be in between. Okay, so these are basic results. Okay, one thing I have skipped, or rather I shifted towards the paper. So okay, so here you can see that it has similarity to the human cerebral cortex. Okay, so 96 convolution kernels for the first convolution layer output you are getting this. So learned by the first convolution, you can see these patterns somewhat similar. If you deal with DIP, you may be familiar with mathematical function formulation of Gabor function. Yeah, these kernels are visually similar, no? Such functions are widely employed in DIP. So for image analysis, visual similarity with our brain, cerebral cortex part, means the outer layer encasing the, okay, means we also see the images in similar light. So it is how you can see it is imitating the human visual system. So this will help in optimizing many things. By the way, this is the Gabor function. You can, means you don't need to mug up, by the way. Okay, so this we have seen. And why the striding is a problem, we will see in just a bit after we finish the paper. So so we have already seen that top error rate is this. Top one error rate is 37.5%, and top 5 is this. Achieved during the 2010 was this. So it was much better. And this competition and report our results in table 2. So they LSVRC they entered, and two classifiers trained on Fisher vectors. So they have, I think, finally fall to 9 version, they were the winner. We can search the internet directly. Who was the winner of VRC20 AlexNet? See, they were the winner on the same, means around 20,000 2,000 categories. So in one part they were second, and basically they were the winner. VGG19 was second, means first runner up. So to reduce variant of this model and achieve a winning top 5, this was variant was winner, and on those datasets they did not. So for one they were not the winner, but for the other they were. So this was their paper. They have told everything, that they have achieved this much of accuracy. So show how large deep is capable. So see how deep learning is so much of capable. It can means it is diverse. It can identify the images which are from many different. It is notable that the network's performance degrades if a single layer is removed. Even if a single layer is removed, for example, removing any of the middle layers lost 2% of the top 1%. So depth really is important, and we will see how it will be very this line is very crucial. This line will change the way the things are. It will change the route. We will dive into the VGG because of this. To simplify, use any unsupervised pre-training. It was supervised, we saw the labels. Okay, so that's it for the AlexNet. Very large deep on video sequences. Yes, that is a very good idea, but at present the IMAGENET itself is a very big data set. Larger and longer training times. I think this also took good much of time. A number of new unusual. The size overfitting is significant. The size made overfitting is even with label. We used training type largest neural networks to date. See, theirs were the largest convolution network at that time, before VGG overtook this credit. So How much time did they take? It was not told. 5 and 6 days. 5 and 6 days to train. See, 5 and 6 days on 2 GTX GPUs, 580, 3 GB died. Means 6 GB GPU, 6 days. Okay, so we are done with AlexNet. Now we come to the basic question, that is why the convolution layer is suffering, if it is, and why we should heed to it. Means pay attention to. Why I have explained, because this network you have seen the performance of AlexNet, but how this convolution layer is getting affected by the striding, we can see. So that's why caps, nets, and many things are there. So striding, but basic is the convolution layer of convolution network. Convolution network is the main player. So striding ignores the Nyquist sampling theorem and aliases, which breaks. Okay, aliasing is a very big issue. Like in movies also, if you focus on old movies, their sampling rate is not that much of high. So if you see some wheel, you will see that the wheel is rotating in the backward sense, and it is this wheel effect. The effect itself is named as in the, and it is having many names, by the way. That effect is having many names. So that I think here, understanding convolution networks, I have read this paper also. So here in one paper it was very clear that why it was, means what is the problem with this. So anyhow, the wheel, I have put one example in for you. So that example is enough. Anti-aliasing and by low pass filtering before downsampling, means before the pooling layer itself we can do with anti-aliasing. That is very much crucial. C1 stroboscope, microscope like stroboscope. So this paper we will see now, basics of the paper, so it will be in few minutes. I hope so. So sample at least. Nyquist sampling theorem is ignored by the striding. So what it says is sample at least twice as fast to keep all the information. If the wheel is rotating at say x speed, you sample it at 2x for having all the information. Otherwise, it will be lost, and you will have that images aliasing. I think I don't have the images, but aliasing effect you may be knowing. I will show you in the paper. Here these images are, see this sample is interfering with this, and you will get a different frequency altogether. So that is what the problem is, that the final image, final frequency. Okay, so there you will get the different image. So here this paper you will get that now pooling builds up shift invariance. Okay, if I shift the image a little bit under this pooling kernel, the maximum will still be the same. Yes, if I shift some image, and the maximum will be under any kernel of my choice, the maximum will be still the same. Not completely bulletproof, but at least locally it will still find the same maximum. So it is shift invariant. But what we have done, we have added the striding thing, and because of that it is no longer shift invariant. So we want that to be shift invariant. In theory, applying a filter kernel to an image should not change the filter response. So in theory, convolution shift invariant. Equivariant. In signal, I thought that if I have written invariant, I will make it equivariant. In signal processing, blurring is used before subsampling. This is anti-aliasing. Okay. That is the only max anti-aliasing before sub. But this max pooling has replaced everything. It has changed but it has demonstrated better performance in empirically, and in total it is better. So we have used max pooling and everything has gone aliasing, shift invariant. So modern convolution are not shift invariant. So a small input shift can cause drastic changes. So this shift invariance thing is really eating it. So average pooling, ignore the sampling. Signal processing is fixed anti-aliasing by low-pass filtering. A signal such as an image, the text box is to anti-alias by low-pass filtering. However, this module into degrades the performance. Okay, simply inserting max pooling. That is why max pooling is not means accompanied with anything, and not activation function. At least somebody told, I will not name that video, but that is popular in data science. So okay, we show that when integrated it is compatible. So in this paper they have showed that they show that they integrated it is compatible with existing max pooling. So they show that when integrated it is compatible with existing architectural. So only the anti-aliasing thing is to be incorporated as per them, and we will see how they have incorporated it and improved the performance of the aliasing, removal of aliasing, and at the same time removing the shift variance. Propose to low pass filter between them. Low pass filter means blurring, as per them anti-aliasing. This is the basic solution, general solution that is provided. Low pass filtering to rather than replace max pooling. So blurring plus max pooling augmented. So here you can see AlexNet on IMAGENET. Okay. So if this is shifted, their performance you can see it is same, but here the performance probability of correct class is changing baseline model, that is the AlexNet, but with their method it is so much of improved. Okay, here also image of some piggy bank. So here also it is different, and anti-aliasing for max pooling. So it is aliased, both are mixed up, but here max, as I told you that in the very beginning of the video I told you that it is in max pooling there are two parts, so they have kept one part and if means made the second part different. So in blurring what happens is that the intensities this happens, and because of that the subsampling result is improved in simpler terms, but they have not explained it so simply. So I will show you what is the problem with this image. Okay, why I am saying that they have not explained it so simply. They are repeatedly, if you see the term occurrence of the term alias. So alias by low filtering. They have not explained aliasing properly as per me. Low filter between them. So if classic A shift equivariance. Okay, so this is the figure, and see for more images they have shown, but I preferred only two because it solved the purpose was served. So here see shift equivariance. If the max pooling is applied, shift equivariance is lost. Then how can you say that here the shift equivariance is not lost? Here if it is lost, this part is lost, this gap, this is lost as per them. Okay, this is green, this is gray, So this is lost. Shift equivariance is lost because of this. Okay, because there is aliasing as per them. Then how come here it is not lost or reduced even? Shift equivariance lost. Okay, here shift equivariance lost. Okay, this is not lost. Okay. Then heavy aliasing, here it is reduced aliasing. Okay, so how can you say that it is reduced aliasing if here it is heavy aliasing? Here there is something in between. Here also there is something in between. So how come it is not reduced aliasing? Okay, my confusion was in aliasing, not in shift equivariance. So heavy aliasing, how can you say here heavy aliasing? It is not heavy aliasing. So anyhow, here it is preserved, the aliasing is removed. But here in subsampling, maximum is taken, and here it's after maximum, the sample is taken out. So during sampling it is lost. So they have, what they have done in this part they have kept as it is, and here they have blurred it before it is given into the subsampling process. So anti-aliasing they have used here. Okay, so other where they have fully utilized of average. So this they have means they have demonstrated, like here this figure is good. So here they have said that from this max pull shift 0, the maximum from this is this 0 0 1 0 1, but if it is shifted, then the maximum is here, max pull here 1 1 1 1 1. So it is means the output is wrong. But here due to blurring, max plus blur here, so max pull shift 0 here, and if it is 1 then here. So here it is means close by. So this they have explained in a better sense. But here the blurring effect, how can means reduce aliasing? If this you are saying that this is aliased, then this is also aliased. But other things they have explained in means good way. So aliasing means I will show you one image, like in shirt. Okay, basically the frequency is distorted. Okay, anti-alias the variant. Here you can see this is the aliasing part. If a good image, if we do it two frequencies, the frequency breaks and sampling rate is high, then something else comes. Like here we can do it. Spatial aliasing. See here, these are the aliasing examples. So here you see this image and this image. Due to that, the sampling rate, the images get distorted. So this is aliasing. Okay, aliased, the smoothness of the edges goes away. So if the gap was there, in the first image, second image was also having the gaps, so you cannot say that it was not aliased strongly. You cannot say like that. So after the max pulling and pooling layers, it all gets affected. The frequency is distorted. The gaps are like increasing, and some other frequency is there. Sampling is different. Then there also the sampling was, both images were having same sampling. One was strongly aliased, one is loosely aliased. How can we say that? heavy aliasing, reduced aliasing. That is wrong, I guess. So we are out of this slide. Now we are here. So aliasing we have seen. Okay. So anti-aliasing is motivated by shift invariance in actual. Okay. Indeed, using bin5 anti-aliasing filter reduces flip rate by 22.3%. True translation. Using bin5 anti-aliasing, these are filters by filter. Bin5 means it will be of very bottom level filter. So it reduces this much. Flip rate means change. 0 will be changed, flip to 1, 1 will be flipped to 0. Okay, so anti-aliasing motivated by shift invariance, blurred and strided convolution all break shift equivariance, spreads sharp image features across their pixel. See, spreads spreads sharp image features across their neighboring pixels. Excellent. So the network's robustness, they only achieve partial shift invariance. So that's why I didn't focus on the paper, because if it is achieving partial shift, but the basics are clear from the paper. The main question due to which I read through that paper, additional paper, was that there is no clear understanding of why they perform these layers, AlexNet, the LeNet, or for that matter VGG19, 11 to 19 layers. There are various VGG architectures. So why they perform so well? What is the construction of the what is the basic architecture? Why they work so well? Whether the neurons are to be in that positions, that orientation, or what, or the architecture, the number of filters is so good, so much apt that it performs well. That is not understood. That is why I went through that additional paper. Anyways, this is the basic difference between LeNet and AlexNet. So you can see from this small image, patch 2, it is improved to this one channel black and white, 3 channels RGB, one channel, okay, whatever, it is improved. Convolution with 5x5 kernel, 2 padding, and see, 4 stride, no padding, and you have this 54. It is means it is or it is twice, I think, means approximately it is twice 56. So here you can see it is not enormous, but it is somewhat increased. That's why it is 10 classes of the digits, and it is 1000. So here you can see the difference. If you have any doubt, you may put it in the comment section below. Now we are finally into our main thing. So it is VGG. It was again in the IMAGENET challenge 2014, similar to AlexNet, but increased number of filters. Yeah, that is the thing. 11 to 19. Yes, addressed effects of depth of convnets in the large scale image recognition settings. Size of connet filters 3x3. It is highly regularized in comparison to the other architectures. Training image rescaling is there, as we will see. Procedure generally Actually, let me tell you, few of the papers which are worth mentioning means Zailer, AlexNet and LeNet. They are good, but apart from them, there are many which motivated the VGG to come to existence. So these are this visualizing and understanding convolution networks. Here they have mentioned LeNet. You can go through these papers on your own because the video will be means it will be extended unnecessarily. I have explained the basic things which will help you get through the VGG any question in VGG basics, because that is the building block. They have regularized in VGG what they have done. They have regularized the structure, and it helped in achieving more accuracy and less error because of that regularization and scaling things incorporated. So it was advanced, more layers, more filters, more depth. So it was very deep. That's why the base paper of VGG says very deep convolution layer for large scale image recognition. So you can yourself imagine from AlexNet we are here in VGG. So understanding the operation of ConNet requires interpreting the feature activity intermediate novel way to map these activities back to the input pixel space. What input patterns originally caused a given activation in feature maps. So it is maps. What is different? What caused this difference? This is its architecture layer above unpooled maps rectify. What is the cause? They have found it. Layer below pooled map feature visualization training details. In layer 5 row 1 called the patches appear to have, so these are the image they have done, appear to have little in common, but visualization reveal this particular feature map focuses on the grass background. So they have, see how in depth they have done. So in this way this paper becomes of importance. And IMAGENET 2012, it was also 2012. Error rate they have compared with AlexNet. Top one, adjust layer, they have got it 10% error. Wow. Top one, validation 38, 16.9. So they have done many things to achieve this. Training images per class classification, this all they have got into the reason thing. So you can go through this. I think that their architecture is not different. So means I have read it, but I have forgotten. 8-layer ConvNet model. Okay, 8-layer. Layer 540C, same 4096. So 384256 basically. So this paper you may go through. I will give you the link to all the papers in my description, or if you ask in comments I will provide you direct links. Then this is another paper that you will find very interesting. If you want to know about the AlexNet architectures, I mean the advanced architectures that are basically using very in-depth analysis of the features in the images, which are the basic things that any robot or any robotic automated system is provided with. So I guess it is hanged. Okay, so integrated recognition localization using this was published in 2014. So nearby VGG. Recognizing the category of dominant in an object is a task to which convolution nets have been for many years. See, dominant object. This is the main thing. Localized detection task. Chosen to contain roughly centered fills much of the image. Okay, so we will go to our basic VGG network. So here I have given you the basic notes. I will provide them, so that will be better if I provide the notes about these two other papers. Rest you will find in the video itself, because it will be too long and the video will unnecessarily be, I think it will be deviated. So sticking to the topic of VGG, Visual Graphics Group. It stands for Visual Geometry Group. Visual Geometry Group, and it reduces the localization error. Okay, size of con nets is fixed. That is a thing. It was not in LeNet. Training procedure et al. Except for training procedure is similar to that AlexNet. Okay, but there is this training is by optimizing the multinomial logistics regression mini batch gradient descent with momentum. We observe that the error decreases with increased depth. Okay, in E, and E in the sense here we have the E. Okay, layers are increased in the VGG, and here the error also decreases. So if it is same, then what is the difference? Okay, what is the difference? Training similar with additional multi-scale cropping. Now we are here with multi-scale rescaling training image size. Let S be the smallest side of an isotropically, means same from training image, each side same. So if there is 226 by 226, then S will be 220. If then each side is 220, and it should be with some symmetry to the center. So that is what is isotropic. Well, so crop size is 2 to 4. In principle, S can take on any value, not less than 2 to 4, because 2 to 4 is to be cropped. So that is what is multi-scale cropping. This term is very confusing. Somewhere they wrote multi-cropping also. So like that they have intermixed the term. So will corresponding, if S is too large, if the side is too large, then the cropped image will correspond to very small part of the object. Two approaches were used for scaling, choosing the scale size, and one is multi-scale cropping. Okay, multi-scale cropping. So multi, I have only explained the scale and cropping, not the multi-scale cropping. So in multi-scale cropping, there are two settings are there. One is multi and one is single scale training. Image content within the sampled crops can still represent multi-scale, by the way, in image statistic. If it is single scaled, still the internal part of the image can still be multi-scaled, means many scales. So and this in the prior art single scale, this single scale training has been widely used in the prior art. Okay, so Zeller, that one paper I showed you, that used this, I will show you. This paper was referred to by the VGG. Okay, so which has means I will show you. Okay, I forgot. this multi-scale okay. Okay, so they have used multiple scales. So those for the fixed scales, this fixed scale has been used. Means this fixed scale, one scale, two scale, only two sizes, s is equal to 384, has been used by Zayler and Fergus. This paper that I showed you, that scale, and s is equal to 256. So these scale sizes have been used, and other speed of the training, s is equal to 384 network has been trained on s256 and smaller initial learning rate, and then tested over the s is equal to 384. So these are the fixed scale, but we are considering the multi-scale cropping. So for multi-scale, what they have done is, since objects in images can be of different size, it is beneficial. So we should test on many scale. During training, by scale jittering, scale we can change, scale jittering can be used, and multi-scale. Okay, we are focused on multi-scale. We are coming, please bear with me. We train multi-scale by fine-tuning all layers, single scale with the same configuration as 384, fixed size 384. Fine-tuning of single with the same. Firstly, they fine-tuned with the single scale so that during training the parameters are same. Data set is okay. Scaling. 4 scales were used by SG. Okay, we are here for multiple scale. What is multi-scale? Okay, then if we are bothered with only VGG, then what is multi-scale? S is multi-scale, where each training image is individually rescaled by randomly sampling S from this range. S mean any scale can be used. This means randomly any scale is picked up for each image. Each training image can have any scale, any of the scale. Okay, so now that we have got to know what is the scale, we are here to obtain the fixed size 2 to 4 coordinate. They were randomly cropped from rescaled training, one crop per image per SGD iteration. Stochastic gradient descent, rescale again, one crop per image. To further augment, the crops underwent random horizontal flipping. So training image rescaling has been done. Everything done. Testing, I think here it is testing. Okay, so here I had already done this. Okay, so dataset results. So dataset classification results achieved by described coordinate dataset. This same dataset 1000 class into 3 set training 1.3, previous was 1.2 50k, and this top one and same top 1 top 5. While more sophisticated splitting up coordinate training have been proposed, which employed model and data parallel for the figure, they have found that while more sophisticated methods of speeding up, so AlexNet was in 2012, so that same author has employed model and data parallelism, but what this paper VGG has obtained 3.75 times. Okay, 6 days was means it will take 2 days, I think. Okay, so on an off-the-shelf 4 GPU system as compared to single GPU using on a system equipped with 4 NVIDIA Titan Black GPUs, training a single net took 2-3 weeks depending on the architecture. Okay, means A to E. Okay, two approaches for setting scale. This I have explained. The second approach is multi-scaling. This also I have explained. Training images individually by randomly rescaling. Okay, so at testing. So we are here in testing, and I guess I have not skipped anything. So here we are in testing. So at test time, given a trained and an input, it is classified in following. Isotope will rescale to a predefined smallest image size. So any image, other image apart from the training, the 1.3 for training and some other k in thousands, it was the test set. It was isotopically rescaled to a smaller site, say q. It can be different scale. It is not necessary that this scale is same as the training scale. So this was used, and you may note that fully connected are first converted to convolution. So all are convolution. The first FC2 is 7x7, that convolution layer. So every layer has become convolution layer during testing. The resulting fully convolution net is then applied to the whole uncropped image. Okay, then this queue comes up. Okay. The result is a class core map. Okay, prediction means number of channels equal to number of classes, and a variable spatial resolution dependent on the resolution, spatial resolution. Finally, to obtain a fixed vectors of class scores for the image. Each class will be getting some score and spatially averaged across the spatial resolution. It was averaged each class. So pooling was there, and the softmax class, this will give you for each class one particular score. So the higher the score, that will be the output, the class will be the output, that is the image. So full one thing is there, full convolution is applied over the whole image. No need to sample multiple crops at test time. So that was the benefit of full convolution. Multiple crops is not needed. This random sample scale that was done during training, that is not needed, but it is less efficient if we use single crop. At the same time, means less accuracy. It requires network computation was reduced. Using large set of crops was done by Vgg et al. So this strategy has been used or not used by this Vgg et al. So but it was very good in accuracy. Finer sampling was there as compared to this strategy of fully convolution. Also, multi-crop evaluation is complementary. If we do multi-crop, then it is complementary to dense evaluation. So dense plus multi-crop, no convolution is needed. Then making all convolution is not needed. So when applying a connet to a crop, the convolved feature maps are padded with zeros. So when a crop is used, the padding is 0, and then the testing is done for the same crops come from the image. While the case of dense evaluation, if we keep it like that, dense, then multiple crops, then it will take it from the surrounding neighbors it will take. Otherwise padding is required for the convolution part, and accuracy is also suffering. So it is means making all convolution is not that much efficient. It is efficient as far as computation goes, but not in accuracy, and the calculation is from the padding is required. which substantially receptive field is reduced also, while in the case of dense the receptive field is increased. And receptive field, I will come back to this topic. This receptive field is again very crucial. And yes, in the 4x4 receptive field, I have not told you receptive field. Okay, I will come here again. Firstly, let me finish this caddy. So, means Scadi did it now. So while we believe they did it, Scadi with a dance layer. So the multiple crops and computation doesn't justify the time. The accuracy is not all everything. So time is also a crucial factor. That's why we can use the convolution in place of dance layer. That is a better option. So for that reason, they have not used the SCADI. For reference, 50 crops per scale they have also used to check 5x5 regular grid, 2 flips, 150 total of 150 crops. So this you can read through in the paper, these numbers. Okay, so I have told you fully connected converted to convolution since is applied to the whole image. No need to sample multiple crops. This I have told you. Everything I have told you. And receptive field, it is very much important thing. You may search about receptive field. It is basically what goes from the image to the output due to both the convolution and while substantially. This receptive field should be improved. Increases which substantially increases the receptive field. This substantially, that is what I'm searching, what substantially improves the. Okay, this same thing that I told you in dense evaluation, we crop and naturally the same naturally comes from the neighborhood. Okay, in dense evaluation, which is very much accurate, that is having high receptive field. Okay, we will focus on that receptive field later on. So it is sort of regularized network. What I have, this is much more regularized. The architecture I am seeing here, pointers I have written in my notebook also, so that I don't forget. Okay, I am thinking what to. Okay, I skip these. Okay, directly to receptive field. A stack of 2 3x without pooling has effective receptive field of 5x5. 3 has 7x7, if 3 3x3. More non-linearity, more complicated decision function. Okay, non-linearity, more ReLU layers, more complicated decision. So it is complicated if more layers are there, more convolution layers. So but the receptive field increases, can be seen as regularization on a 7x7 filter, so forcing them to have a decomposition. So we can see that more the layers, more simple terms, we are regularizing, having more receptive field. uh, Models generalize well to a, if we construct a model wide range of tasks to do wide range of tasks, data set matching or performing more complex, then we need more deep networks. That is what this says. And I will show you the architecture of the VGG19 after so much of discussion. And they took weeks to train, so many weeks, sorry, so much of time. So it is a very highly consuming network. Okay. By the way, let us see how much of this is same AlexNet. I explained LRN. This is what is remaining. No, I explained it in that. What? I explained it in AlexNet, I guess. So here, what these are: conv3128, receptive field, number of channels. Okay, this is receptive field. Here, these are receptive field, not the block number. Sometimes there in the implementation you will see block 1, conv1, 2, block 2, conv1, 2, block 3, but it is receptive field. Labeling is different. Be cautious. So here LRN, again LRN, and after B you will see that they have left the LRN because it didn't improve, rather it it increased the error. So that's why test train S, scale and Q. So these are sides are different, so it increased the error rate. That is why they left. So ReLU layer is there, non-linearity. ReLU non-linearity is there. So here you can see that this LRN normalization, this normalization is not of any use. Local response normalization, so they remove the normalization part. Directly ReLU, unlike the AlexNet part, AlexNet did the normalization and anything, but they here VGG didn't find it useful. They removed it. In the same dataset, ILS VRC dataset, uh, dataset dataset was same, but which dataset? 2012 14 challenges, 2012 dataset, not the 10 which was used by AlexNet. Okay, 2010, 2012 was also used by AlexNet. 2010 was having labels, test labels, and here 2012 was not having. And 2012 to 14, this same dataset was used since AlexNet. So same AlexNet also used this dataset. So let me verify AlexNet dataset. AlexNet, see 2012 dataset. So same dataset. So we have seen this and this. So finally I am concluding this and searching for better and deep neural network. Till then, in search of better and better options, I would like to thank you for having peacefully listened to everything that will help you in the theory part. Now, implementation part. If you are not interested to know how to implement the VGG19, actually there are many videos for VGG16, but there are none for the VGG19, and they do tell that there is one VGG19 from the Keras API and we should pass on the IMAGENET. No, I say no. IMAGENET is not compulsory that we give the IMAGENET dataset. We can use any dataset, and it is not necessary. One of the very famous YouTuber, whatever, he told that it should be ImageNet in the function, and VGG19 should be from the Keras API. I say no, both no. ImageNet, it is not necessary in the argument you put ImageNet, and not necessary VGG19 from the Keras API. So having said that, let us head on to the implementation.
Okay, then take the thank you to the end, append it in the end, and we are now on to the implementation part, and it will be really very much enjoying. So in the implementation part, I would like to tell you that we are now in the implementation part, but there are many confusing things, means there are many variety of weights in VGG19 network. I will show you in this concluding part that customized VGG19 is also possible, and the VGG19 from the Keras API
built-in Keras API is also possible with two options of IMAGENET weights data set and also other option of weights which can be downloaded from some source. So this weight downloading led me to discover many other variety of VGG19. So some video told that it should be ImageNet should be written as the parameter. No, it is not necessary. We can customize the weights as per our intention. We can download any of the weights and use them as good. It would be as good as ImageNet parameter. So I will show you one of the means starting from that Euler library. Euler dataset was there, some no top. Yes, and further there are two more options with top and no top. No top means top layers are not there. Top layers are not there means dense layers, the three dense layer. You maybe recall, you will if you recall it, you will get that there were three layers at the top. It is called top. The dense layers are the top layers. So these layers are with and without. We can use the weights. So this Euler layer, we can check that these are the layers. Here they have defined it very quite differently, because you can see that this activation layer is at very beginning and means it should be bottom, and these layers are continuous without the max pooling layer, and flat and dense layers are in between. So top layers are somewhere else. So it was there, it was named as no top. So I took it. So this is one of the variant, and when I use this layer, then I get the error that this is somewhere mismatch, and this error is for the bias kernel 0. Wait a second, this is for that Euler. Yes, Euler. So there is one error that it is some bias was actually it was some bias error. If I change this 64, let me do it. So there is error in the weight, this weight function, because it was meant to be, if you are able to recall, it was meant to be of 224 the original patch size that is to be input. So I have used this target size. So it was the target size 224 So I have used this same 224 Here I changed it so that maybe I will not get any error, but it still gives me error. I am running it on GPU. Let us see. It will quickly execute, and if there is some error, it still gives me error because the weight function is having weights are having some error. I will also show you real world classification of any of images. It will classify among the 1000 classes, one amongst them. So here kernel 0 shape mismatch 33364. So what I will do here, see third, in these two are interchanged. I checked all the parameters 64. If I change them, and see third parameter is changed, so third dimension is changed. So what I will do, I can change these, and at one point it gives me that the bias, there is bias error. So I think bias of 0 conv 2d kernel 0. So kernel 0 conv 2d kernel 0 means this conv 2d layer, because its name is conv 2d. So here kernel is having error. So if I go on improving at 1.33, this all matches. I do some input modification. Now I am running on the correct input size. But if I make modification, so somehow it runs on kernel 0, but then it strucks on bias 0, this same layer's bias, and it doesn't run correctly. So I think this layer is having error, kernel 0, and if I changed according to this layer, then it strucks in bias. So now
going towards the actual VGG19 implementation, and as I told you that we can do it for both layers, means both ImageNet with ImageNet inbuilt data weights and without. So I will show you both with and without the ImageNet weights. So ImageNet target size, see here 224223, as you can recall. Flattening of output is there. So here you can see I have used customized function VGG19 with underscore. So it is not the Keras inbuilt function. You can see from the beginning I have imported this sequential model, and basically in sequential model we have that model.add. So it is sequential model, then flat and dense dropout, and this dropout I explained. These layers are there, zero padding. Either you can use in max pooling the parameter padding is equal to same, or you can use the zero padding. Okay, so both are same, effectively same. And SGD, these all I have imported. TensorFlow as TF, I can remove this line. Keras, everything I am using TensorFlow 2.5.0 Keras in under this same. We can check the version also, but and now I am doing the implementation part. Okay, let us check the version of Keras and TensorFlow. So I will check the version of Keras and TensorFlow in a short while. Before that, the main thing that okay, I will check. I think both are same. Let us check the version of the TensorFlow and Keras we are using. So the command for that is Keras. The command for that is Keras dot underscore version underscore. Why is it giving the error? Okay, let us see. Let us see why is it 2.8.0. Same 2.8.0. So it is the updated version. 2.8. This is the latest version. So I have this target size. Okay, so here I have this extra. So this is gone now. I am using this customized thing, and with the customized layers I am not having the weights ImageNet. From the ImageNet parameter I am having this weight, and this is having no top false. So let us see. Model is not defined. Or rather, this I have customized, this name I have given. So this may be something else. So here we have all the layers, dense layers, 3 no top, dense layers
as per our need. This layer is there as dense layer. VGG19. So this function, convolution, max pooling convolution, 2 convolution layer, then max pooling, then 3 convolution layer, 4 convolution layer, max pooling, 4 convolution, then max pooling, 4 convolution, max pooling, then flatten and then dense. One dense layer is there. Yes, I have added the layer. Here. So here I have added the layer. So you can see that it is a customized VGG. I can add because it is no top. This means I have customized the name. Sorry. It is no top version of that. Okay, so I have shown you this customized running of the VGG19. I can add 3 dense layers also. I hope you understood this. But so I can do it, and one more thing, I can print what this is. Which class does this belong to? How can I do it? I will check. I wanted to tell you how to, means there are many varieties of the weight file. When you search now, you will get confused. Like here you see no top. For no top there are 2 files. One is like this is VGG19 weights. So but finally when you run you get to know that it is for 16 layers no top. So I will give you the source. I will provide you the files directly, the weight files. When you download this file VGG19 weights, you search the whole internet and you don't get the weight files. You have to use the IMAGENET direct parameter, but I will provide you the correct file. There is one correct file in the internet which is very difficult to find out if you don't use the VGG19's inbuilt keras function and that parameter as ImageNet. So in any case, here we have and same is for keras. Actually, I was myself confused with the files, so it was giving me errors. Then I checked which file is correct. These are simple, means now I have, what I have done is I have diversified for each variety with ImageNet, with customized function, without customized keras API, with ImageNet argument. I have customized each and everything, and I will slowly show you how to use the weights from that. So I have this file. This is showing me error, and which variety it is? It is without top. Yes, there is one top, with top, without top, customized function, customized weight with ImageNet. So yes, I would like to tell you one more thing. There is one mistake, silly mistake, you can say, that is there, that this bracket should be here. If this bracket is placed here, or it is not placed, like I do this, then what will happen is the stride, it will take 3s stride and the third dimension will be ignored, and that I guess you don't want. So better it be placed at its correct position. So you should check this. These are silly mistakes, no one will tell you, but I wanted you to know it for having the smooth. So it is without no top, and I am using the customized function without top and customized weight. So firstly I will hide these functions because these are tens. I have made the function as per the detailed theory I gave you. And these import keras, import TensorFlow, import sequential model dot add means it is a sequential model, flatten, dense, drop out, everything I have told you already. And VGG19 if you use the inbuilt function. As I was showing every variety, so I have same copied every import, so you may remove it here for now because I am using the customized function. So also TF TensorFlow is already imported, so pre-process, we will pre-process so that the image is clearly it is distinguished and it is not classified to some other class. So this dance flatten lambda layer, it may be used for adding layer. Input layer we will specify in the, because it is customized, you may check. So load, image load, if you are using the image load function, it is the best option you have. Like see, here you can specify the target path, grayscale. There is so much of means color mode, path to image file. You can use this function directly to have the cropping done by it. So here you have done, you can check various parameters. You can do it without pre-processing. You can pre-process it by your own, and you can do many things pre-process. But we will use means it's pre-processing, and we will image to array is necessary because we are doing the numpy thing. So here numpy dot expand is necessary. We are having 3D, not 2D. So 3D, so it is necessary. Then you will have this object VGG19, your customized function. This is the correct weight file without top. We have hidden this. So flatten is done. I guess flatten is to be removed. Anyways, let us see. And so it will be, X will be VGG19 dot output. Okay, its output will be here, and dense X for this its input, that model same input will be fed now with this dense layer. So new model, this is different, this is different, but both are having same input, and output will be from this dense. One dense is necessary so that we can have 1000 classes. So everything is perfect. Pre-process, we have done this pre-processing from the inbuilt module, pre-process module, and from model we are having the prediction in the output. Whichever prediction is the highest, that is the our required output. Decode prediction, these functions you may have detailed reading of it with from their documentation. That will be much better. So this is decoded, and result is in the string. String version we want it to be written in the plot title. Okay, so we are good to go, but it will give us error. Let us see what is the error. And the zeroth means the whole image. The image will be in the 4D dimension, but we want it 3D. So anyways, so there is no error. Jellyfish, I guess it has flattened it here. Here it has been flattened, so we are easily getting the 1000. So it is classifying this image as jellyfish. We are using everything customized. See, I have not used any inbuilt module, inbuilt neither inbuilt weight nor inbuilt function. So let us see. And no top, mind you, no top has been used, means dense layers are not there. Now with inbuilt ImageNet, okay, let us see. With inbuilt, weights will be provided by me without that ImageNet, but again no top. Okay, inbuilt function, but this time it is inbuilt function. So include top is simply include top is false. This function we may delete it. Okay, we may delete this whole line, whole code we may delete because it is using inbuilt. So maybe this function may go wrong. So I have commented the part so that okay, so it is classifying it as Bagel. This is the VGG19 code, by the way. So what is Bagel? Let us check just for knowledge. So it is Bagel. It is classifying that image as Bagel. Anyhow, it is dark, so it may be Bagel. We may check it with another image, cat image. Let us see what it classifies without top. So it will not work that efficiently because it is without top, but it is inbuilt. Weights I am supplying. Trench coat. Trench coat. Let us see. This may be some. I know what it is, but let us see how trench coat. So it is qualifying it as trench coat. Okay. Anyhow, the last top layers are missing. So jellyfish sometimes trench coat. Top layers. We are doing it without top layers. Okay. So wherever it is without top layers, let us finish that first. Without top layers, with IMAGENET we can do it. Without top layers and with IMAGENET. Okay, IMAGENET. Okay, so what we can do is here we can do is this time we will be using IMAGENET. Like somebody told that IMAGENET is a must. I said no, IMAGENET is not a must. So let us see with IMAGENET this time. Okay, but without top. IMAGENET, everything is now inbuilt. Function is inbuilt, that is inbuilt, weights are inbuilt, everything is inbuilt. Let us see what it does. It will predict, I think, the same. Means without top layer, so its efficiency will suffer, but let us see. So let us see what it does. So IMAGENET is I think it is capital. Okay, IMAGENET. Okay, I have used IMAGENET somewhere. I think the spelling or case sensitive. I've not done case sensitive search. Achha, it should have, okay, it should have quotes, single quotes. Okay. Weights argument should be either none, IMAGENET. Okay. So I should be small. Let us see what happens. This time again trench coat. So same classification. Let us see. It is no top. Okay. So it is no top. Okay. So we are done with no top. With inbuilt weights, inbuilt customized weights, customized function. Okay. Customized function. Okay. So now see without top. These were inefficient as we have seen. Let us see one more image, but these are inefficient. You can see these are inefficient. So let us do with one more image. small 2. Brain coral. So it is inefficient anyway. The image has also weird. So we are done with no top in all ways. In customized layers, we cannot have the inbuilt weights. We can, if we customize it in that way, we can do it that. Anyways, customized layers mean we can customize everything. Okay, so without top we are done. Now coming to with top. Without ImageNet. Inbuilt model. We are using inbuilt model. Okay, so inbuilt model, let us see. See here, train path we can save it anywhere. Anyway, we are not training, it is using pre-existing weight, and image size is also not needed. Okay, prof picture. Okay, this image is used. Image, NP expand, everything. If we want any layers, like sometimes we train only the top layers, means dense layers, so for that purpose we can use this. And so we are using inbuilt model but customized weights, and top is there. So let us see for this image. Any doubt you may ask me, means if any variant is remaining, then also you may consult me. So this is inbuilt function, so these are not required. This is bonnet. It is, see, after we include the 3 layers, it is so much of close bonnet. I hope you know what is bonnet. So it is inbuilt, that is why we can comment everything here. Okay, I have commented because it is using inbuilt model. So as you can see, it is recording. Okay, so you can see that it is close by. Now I change the image. Okay, cat. With top, because it is using the dense layers. Actual Egypt, see how much it is accurate. Okay, so let us 2 is enough, and cat is identified. What extra do we need? That is enough. So here again top is included, but this time we are using manual top layers manually. These are needed this time. Let us see what bonnet. You have seen that it will predict the bonnet correctly. Meanwhile, I tell you that what is okay. It is bonnet. It has come. GPU is used, so it is fast. So here we can use cat again. It will predict that also correctly. And so here decode predictions. It will decode the predictions, means it will find out the exact value for that prediction. Egyptian cat, again same. Let us see for the other image, small 2, or we can use some internet image. Let us first do this, then see some small 2 image from the internet. We can take directly bathing cap. Yes, this is cap type. Okay, so it is close by, or we can download some trench coat image. Yes, we can save this image. or we can save this image. Desktop, or here also we can save shopping.png, because I think Google Drive doesn't do that. What means it doesn't do what it doesn't do? It doesn't do that thing. Means it directly internet, it will not pick. Okay, we can directly so we can use this direct and let us see what it predicts. Nematode. This image, I think it is not visible. Okay, due to this processing, this is to be blamed. This processing is to be blamed. So what we can do, if I don't do the pre-processing, let us see. Mosquito network. So pre-processing was helping. Okay, it is black. Anyways, PNG image. Okay. If I mosquito net anyhow. Pre-processing is bad. Clipping input data to valid range for I am show. 0, 1 for floats. Okay, I got it. So it is mosquito net. It is wrongly predicting. Okay. But decode prediction is specific to the IMAGENET, so that's why I didn't read it, because it is specific to that data set. NumPy array encoding a batch of prediction. Top guesses to return. Okay. Array encoding a batch of predictions. So what is the size of this prediction? So top predictions. So output will have prediction tuples, class name, class description, score. Okay, so it will have class name, class description, score. So we need the top scorer, only one. So one will be returned. Class name, class description, score. One list of tuples per sample. One list of tuples per sample in the batch. So its class for each sample it will predict. We have one sample, class name, class description, score, top one. So its class name we need. Okay, so we need its class name. Okay, so it is done. 0, 0 first class name, NumPy array encoding a batch of prediction, 0 class description, yes 0, and its score. But we need 0, 0, top 1 we have asked. So it will give us result in string format if we list out one item on it and its class ID or whatever, and this description. We need the description. Okay, only one item is there anyhow. So we need what? We need 0, 0th means first, and first it's what? It is its, what is it? It is its class description. So we need this class description. So 0, 0, 1 list per sample. If we, for instance, do it 2, then it will 1.1479. Let us see. Okay, so it is like that only. It is giving us the third is score. We don't need the score. We need the class description. So that is how it is. And out it is of no use because it is a list. Anyhow, we are seeing it in the description. Now I checked the output some time back, but it was of no use. So that is done. Then top with what variety variant is remaining? With top layers VGG19. With top layers VGG19. This is both variants, everything combined. But we need, yes, we can print the weight files of like Euler. Here you see that everything is there in one go. Convolution layers are together, stacked together. Max pooling layers are together. So it is not good. And there you also saw the error. And okay, where is that shopping.png? Manual top layers. Where is that shopping? Okay, so I removed that. It was not classifying properly. I think that is why I removed it. But now we are using the VGG19 customized function. Now in customized function, let us see if it is same. Okay, we did it in customized function. And let us see shopping.png. And 0, we need only the description. Shopping.png. Okay, content. Okay. This. We should do some good pre-processing. Then it will be very effective. Net nematode. So the pre-processing matters even with this network, or maybe it is not efficiently used. Top 5, let us see. For the 5th, 4th it will be. It is nematode. So it will be 4th. Let us see directly. Digital clock, hourglass. So it is not able to see the image properly. Okay. I think image to array. So it is not able to process it properly. Pre-processing function we may use in a better way. Anyways, all the 4 outcomes we have seen. Okay, I can print it also. 1 2 0th 1 2 3 4 lighter. Okay, it is not able to identify. We may use any other image. Okay, coffee mug, that is very famous. So let us see for it. Coffee mug. Okay, save image. This is a cute. Okay, save image. There is no such option. Okay, save image is here. Save. Okay, let me save the image first. I am pausing. So we have saved the image. Now we are using this. Okay, here, and renewing will become okay. Let us see whether it is able to predict the cup. Okay, cup, we have to check. JPG image it is. Coffee mug, see, it is correctly predicting. Let us see what are the other predictions it has made. Maybe it will be very interesting and funny. So let us do one thing. I am running the whole code again. Let us see if there is some cup. Coffee mug, then a cup. It is cup. Coffee mug, cup. Cup. Coffee pot. Pitcher. So it is very close by. Coffee mug, cup, pitcher. Last one is so we can do the classification with VGG19 very easily, as you have just seen. It is very easy to do the things. provided that you have the correct weight files, correct guidance. Okay, I have not used the IMAGENET, I guess, because image salt shaker. Oh yes, this can also be there. It can also be salt shaker, but I have not used IMAGENET, I think. Manual top, manual, it is good, but IMAGENET, with IMAGENET I have not done, I think so. So if I am doing again, then okay, I have done with IMAGENET. IMAGENET weights is equal to IMAGENET. Without IMAGENET it is. I'm saying without IMAGENET. Without IMAGENET is not to be, it is to be with IMAGENET. So I ran it. Okay. So brain coral. So with IMAGENET, so it loads, means it consumes some bandwidth while loading the data set. And let us see if it is shopping is include top. We can make it true also. True. Click top is true. I don't know whether I have shown it already. And we can change the image also. See the top ImageNet file as American aggregate. What is that? The image is not clearly visible. Cup.jpg was visible. 5. Cup.jpg will anyhow. So we can use any of our images and pre-process it according to our need. So that will be much better. Pre-processing as per one's need. That is much better. American aggregate, torch, car wheel, pot, plunger. It is not able to see the image, I think. If I do the pre-processing, then it will be. In the meanwhile, we can check the cup.jpg. Was. Okay, no problem. Was, moped, American aggregate, barn spider, bolo tie. Even though it is having the dense layer, not this, this is customized, but even though it is having the dense layer, still it is not giving the correct result. Okay, anyhow, means the customized was better. So cat, for cat at least it will give, I think. Okay, anyhow, cat one it will give, I guess, hope so. Cat image, let us check once, and then we are done. We will wind up. I think I am being very, means my voice is audible or not, I am not sure, but I will check. Rapeseed, what is that? Anyways, let us see if one of the options is cat. Oil filter, jack-o'-lantern. Means this ImageNet weights is not working for me. Lantern, platypus, menu. What is menu? Platypus, jack-o'-lantern. No one is having the option flagged flashing in a cat flag. It should at least be something similar. Okay, anyways, I think I should stop here. It is not working, but it is. I have not used any of my inbuilt things. You can see it is commented. IMAGENET, nothing. I have done nothing for this. Include top true IMAGENET. It was better when it was false, I think. IMAGENET, this weights is having the issue. Trench coat. See. Out. Okay. Then I am done with the implementation part. Trench coat. It is not giving correct output. I have, as you can see, I have used the IMAGENET strawberry, rain barrel, parallel bars, tiger cat. Okay, I got it. I should not have used this. Out. Because it was for the not having that last layer when I was not using a top. Okay, so with top, it is therefore it is not that easy as it seems. With top, without top, it is totally different. IMAGENET VGG19 include top true. I can change it to IMAGENET. Okay, that was the error then. We should not do anything. Directly out should be used. So I got my error, and now it will be rectified. Egyptian cat. Even if I use IMAGENET, I thought because the weights are same, even if I use IMAGENET, but I thought maybe I have used it wrongly. So it is correct. IMAGENET top 5. If I use this now, shopping.png, that is, this image is not preprocessed, so let us use this, and last we will do it. So you can see it is correctly predicted. Coffee mug. So yes, IMAGENET, whether you do it with IMAGENET, whether you supply the weight file, that both the things are same. so 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 that's it. Hopefully you enjoyed it. I hope if you did. So 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 that's it. Hopefully you enjoyed it. I hope if you did. So 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 that's it. Hopefully you enjoyed it. I hope if you did. That's it. Hopefully you enjoyed it. I hope if you did. So 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 that's it. Hopefully you enjoyed it. I hope if you did. So 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 that's it. Hopefully you enjoyed it. I hope if you did. So 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 that's it. Hopefully you enjoyed it. I hope if you did, that's it. Hopefully you enjoyed it. I hope if you did, so 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 I hope if you did, that's it. Hopefully you enjoyed it. I hope if you did, so 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 that's it. Hopefully you enjoyed it. I hope if you did, so 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 that's it. Hopefully you enjoyed it. I hope if you did. So 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 that's it. Hopefully you enjoyed it. I hope if you did. That's it. Hopefully you enjoyed it. I hope if you did. So 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 that's it. Hopefully you enjoyed it. I hope if you did. That's it. Hopefully you enjoyed it. I hope if you did. So Okay, so having given every detail of the VGG19 network, having told everything that is involved in the VGG19 network, having said everything, having done everything related to VGG19 and given you the demonstrations, the implementation code. So given everything, I would like to tell you that you may subscribe to the channel so that you get more such videos, more such information and related stuff. If you want more such videos, please do subscribe to my channel. And also, I ask you to ask me questions in the comment section, so that I will be getting back to you. I will provide you more material related to this video, as I told you, like those convolution layer based everything I will try my best. You provide me the comments that whatever you are getting stuck in, so that I can improve it with the answers and removing your doubts. So, and also give my video a thumbs up so that I also know that you are liking such videos and give you more implementation, more code and more details. So keep on pre-processing your data and everything. So that's it. Thank you very much. See you next time.